Master of Architecture. MH4202. Climate Change Adaptation and Resilience in Architecture. Subject Concept Outline and Short Notes. Objectives. Climate change adaptation and resilience in architecture. Climate change adaptation and resilience are crucial considerations in architecture as they address the growing threats posed by climate change, such as rising temperatures, increased frequency of extreme weather events, sea level rise, and water scarcity. Architects can contribute to climate change adaptation and resilience by designing buildings and structures that are more sustainable and resilient to the impacts of climate change. Here are some ways in which architects can design for climate change adaptation and resilience. Passive design strategies. Architects can incorporate passive design strategies such as natural ventilation, daylighting, and shading to reduce the energy demands of buildings, minimize the need for mechanical cooling, and create comfortable indoor environments even in extreme weather conditions. Sustainable materials. Architects can use sustainable materials that have a low carbon footprint and reduce the environmental impact of construction. This includes using recycled materials, sustainably sourced wood, and energy-efficient insulation. Green roofs and walls. Green roofs and walls can help to mitigate the urban heat island effect, improve air quality, reduce stormwater runoff, and provide habitat for wildlife. They can also help to reduce the energy demands of buildings by providing insulation and shading. Resilient infrastructure. Architects can design buildings and structures that are resilient to extreme weather events such as hurricanes, floods, and wildfires. This includes elevating buildings in flood-prone areas, designing buildings with robust structural systems, and using materials that are resistant to high winds and fire. Water conservation. Architects can design buildings that conserve water by incorporating low-flow plumbing fixtures, rainwater harvesting systems, and greywater recycling systems. These measures can help to reduce water demand and ensure a reliable water supply even in times of drought. By incorporating these strategies into their designs, architects can help to create more sustainable, resilient, and adaptive buildings and structures that can withstand the impacts of climate change. Give understanding of the effects of climate change at global and India levels. Climate change is having significant impacts on the global environment, leading to a wide range of consequences for ecosystems, societies, and economies. Some of the effects of climate change at the global level include rising temperatures. Global temperatures have been steadily increasing due to climate change, leading to more frequent heat waves, droughts, and wildfires. These changes can have significant impacts on agriculture, water availability, and public health. Sea level rise. Rising temperatures are causing glaciers and ice caps to melt, leading to sea level rise. This can lead to flooding and erosion of coastal communities, loss of biodiversity, and damage to infrastructure such as roads and buildings. Changes in precipitation patterns. Climate change is also leading to changes in precipitation patterns, with some regions experiencing more frequent and severe flooding, while others experience drought and water scarcity. In India, the impacts of climate change are already being felt, and the country is considered one of the most vulnerable to the effects of climate change. Some of the effects of climate change in India include increased frequency of extreme weather events. India has experienced a significant increase in the frequency and intensity of extreme weather events, such as floods, cyclones, and heat waves. These events have caused significant damage to infrastructure, crops, and communities. Water scarcity. India is facing increasing water scarcity due to changing precipitation patterns and overexploitation of groundwater resources. This has led to water stress in many regions, particularly in rural areas. Agriculture impacts. Climate change is also affecting agriculture in India, with changing precipitation patterns and rising temperatures leading to decreased crop yields and increased crop pests and diseases. Health impacts. Rising temperatures and changing precipitation patterns are also having significant impacts on public health in India, leading to an increase in vector-borne diseases such as malaria and dengue fever. These impacts of climate change in India are likely to continue and exacerbate in the future, highlighting the urgent need for climate change mitigation and adaptation measures in the country. Explain about vulnerability assessment methods in climate change. Vulnerability assessment is a method used to understand the potential impacts of climate change on a particular system or community. It involves identifying the exposure, sensitivity, and adaptive capacity of a system to the potential impacts of climate change. There are various methods and approaches used in vulnerability assessment, and some of them are explained below. Exposure-based methods. Exposure-based methods involve identifying the physical and spatial exposure of a system or community to the potential impacts of climate change. This involves assessing the extent to which the system or community is directly affected by changes in temperature, precipitation, sea level rise, or other climatic factors. Sensitivity-based methods. Sensitivity-based methods involve assessing the degree to which a system or community is vulnerable to the impacts of climate change. This involves considering the susceptibility of the system or community to the potential impacts of climate change and the ability of the system or community to adapt to these impacts. Adaptive capacity-based methods. Adaptive capacity-based methods involve assessing the ability of a system or community to adapt to the potential impacts of climate change. This involves considering the social, economic, and institutional factors that can enable or constrain the adaptation of the system or community. Composite-based methods. Composite-based methods combine exposure, sensitivity, and adaptive capacity assessments to provide a more comprehensive understanding of the vulnerability of a system or community. These methods aim to capture the complex interactions between climate change impacts, social and economic factors, and adaptation strategies. Vulnerability assessment methods can be qualitative or quantitative, and they can be applied at different spatial scales, ranging from the local to the regional or national level. The choice of method and approach depends on the specific context and the research question being addressed. The goal of vulnerability assessment is to provide information that can inform decision-making and support the development of effective adaptation strategies to address the impacts of climate change. Give knowledge about strategies and methods in the design of built environment for adaptation, mitigation, and resilience with respect to climate change. Designing the built environment for adaptation, mitigation, and resilience is a critical approach in responding to the challenges of climate change. There are several strategies and methods that can be used to incorporate climate change considerations in the design of the built environment. Passive design strategies. Passive design strategies, such as natural ventilation, daylighting, and shading, can reduce the energy demands of buildings, minimize the need for mechanical cooling, and create comfortable indoor environments even in extreme weather conditions. Passive design strategies can also help to reduce the greenhouse gas emissions associated with building operations. Sustainable materials and construction practices. The use of sustainable materials and construction practices can reduce the environmental impact of construction, lower carbon emissions, and reduce waste. This includes using recycled materials, sustainably sourced wood, and energy-efficient insulation. Green infrastructure. Incorporating green infrastructure, such as green roofs and walls, rain gardens, and permeable pavements, can help to reduce the urban heat island effect, improve air quality, reduce stormwater runoff, and provide habitat for wildlife. Resilient infrastructure. Designing buildings and structures that are resilient to extreme weather events, such as hurricanes, floods, and wildfires, can reduce the vulnerability of the built environment to climate change impacts. This includes elevating buildings in flood-prone areas, designing buildings with robust structural systems, and using materials that are resistant to high winds and fire. Energy-efficient systems, incorporating energy-efficient systems such as LED lighting, high-efficiency HVAC systems, and renewable energy technologies, can reduce the energy demands of buildings and lower greenhouse gas emissions. Water conservation, designing buildings that conserve water, using low-flow plumbing fixtures, rainwater harvesting systems, and greywater recycling systems, can help to reduce water demand and ensure a reliable water supply even in times of drought. Community engagement and participation, engaging communities in the design process, can help to identify local needs and priorities, ensure that the design is culturally appropriate, and increase community support for the project. This can lead to a more sustainable and resilient built environment. By incorporating these strategies and methods in the design of the built environment, architects and designers can create more sustainable, resilient, and adaptive buildings and structures that can withstand the impacts of climate change. Give knowledge about government policies with respect to measures regarding climate change. Governments around the world have recognized the urgent need to address climate change and have implemented various policies and measures to reduce greenhouse gas emissions, adapt to the impacts of climate change, and transition to a low-carbon economy. Some of the key government policies with respect to climate change include national climate change strategies. Many countries have developed national climate change strategies that outline their plans for reducing greenhouse gas emissions and adapting to the impacts of climate change. These strategies typically include a range of policies and measures, such as renewable energy targets, energy efficiency standards, carbon pricing, and investments in adaptation measures. Carbon pricing. Carbon pricing policies, such as carbon taxes and emissions trading systems, aim to put a price on greenhouse gas emissions and create incentives for businesses and individuals to reduce their carbon footprint. Many countries, including Canada, the European Union, and China, have implemented carbon pricing policies. Renewable energy targets. Governments have set renewable energy targets to increase the share of renewable energy in their energy mix and reduce their dependence on fossil fuels. For example, the European Union has set a target of achieving 32% renewable energy by 2030, while India has set a target of achieving 175 gigawatts of renewable energy capacity by 2022. Energy efficiency standards. Governments have implemented energy efficiency standards for buildings, appliances, and vehicles to reduce energy demand and greenhouse gas emissions. For example, the United States has implemented energy efficiency standards for buildings, while the European Union has implemented energy efficiency standards for appliances and vehicles. Adaptation measures. Governments have implemented adaptation measures to help communities and infrastructure adapt to the impacts of climate change, such as sea level rise, flooding, and extreme weather events. This includes investments in infrastructure, such as flood barriers and seawalls, as well as the development of early warning systems and disaster preparedness plans. International agreements. Governments have also entered into international agreements, such as the Paris Agreement, to address climate change on a global scale. The Paris Agreement aims to keep global warming below 2 degrees Celsius and pursue efforts to limit it to 1.5 degrees Celsius and includes commitments from countries to reduce their greenhouse gas emissions and adapt to the impacts of climate change. These government policies and measures are critical in addressing the challenges of climate change and transitioning to a low-carbon, sustainable future. However, there is still a need for continued action and cooperation at all levels of society to effectively address climate change. Give knowledge about Indian government policies with respect to measures regarding climate change. The Indian government has implemented various policies and measures to address climate change, recognizing the urgency and importance of this global issue. Some of the key government policies with respect to climate change in India include National Action Plan on Climate Change. The National Action Plan on Climate Change, NAPCC, outlines India's plans for addressing climate change through various mitigation and adaptation measures. It includes 8 national missions, such as the National Solar Mission, the National Mission on Sustainable Habitat, and the National Water Mission. National Solar Mission. The National Solar Mission aims to increase India's solar energy capacity to 100 gigawatts by 2022, making it one of the largest solar markets in the world. The mission includes incentives for the deployment of solar energy, such as feed-in tariffs and tax incentives. National Mission on Sustainable Habitat. The National Mission on Sustainable Habitat aims to promote sustainable and low-carbon urban development, including energy-efficient buildings and transportation systems, waste management, and green infrastructure. Energy efficiency programs. India has implemented various energy efficiency programs, such as the Perform, Achieve and Trade (PAT) scheme, which sets energy efficiency targets for energy-intensive industries and provides incentives for exceeding those targets. Clean energy finance. The Indian government has established several financial mechanisms to support the deployment of clean energy, such as the National Clean Energy Fund and the Green Energy Corridor project. International agreements. India has also committed to international agreements, such as the Paris Agreement, and has pledged to reduce its greenhouse gas emissions intensity by 33 to 35% by 2030, compared to 2005 levels. Climate resilience. The Government of India has launched several programs for building resilience to the impacts of climate change, such as the National Adaptation Fund for Climate Change, NAFCC, and the Coastal Disaster Risk Reduction Project. These policies and measures demonstrate India's commitment to addressing climate change and transitioning to a low-carbon, sustainable future. However, there is still a need for continued action and cooperation at all levels of society to effectively address climate change. Unit 1. Introduction to climate change. Climate change refers to a long-term shift in the Earth's climate system, including changes in temperature, precipitation, and weather patterns. The main cause of climate change is the increase in greenhouse gases in the atmosphere, particularly carbon dioxide, CO2, which is primarily produced by human activities such as burning fossil fuels, deforestation, and industrial processes. The impacts of climate change are widespread and potentially catastrophic, including more frequent and severe weather events such as floods, droughts, heat waves, and storms, rising sea levels, melting glaciers and polar ice caps, and changes in ecosystems, biodiversity, and food production. Addressing climate change is one of the greatest challenges facing the world today, requiring urgent action to reduce greenhouse gas emissions and transition to a low-carbon, sustainable future. This involves a range of strategies and measures, including transitioning to renewable energy, improving energy efficiency, promoting sustainable land use practices, and building resilience to the impacts of climate change. Climate change across history. Climate has been changing across history, but the current rate and extent of climate change are unprecedented in the last 800,000 years, according to scientific evidence. Natural factors such as volcanic activity, solar radiation, and changes in the Earth's orbit have influenced the Earth's climate in the past, but the current warming trend is mainly due to human activities. Before the Industrial Era, the Earth's climate underwent natural variations, such as the Little Ice Age and the Medieval Warm Period, which occurred from the 14th to the mid-19th century and from the 9th to the 13th century, respectively. However, these variations were regional and relatively mild compared to the current global warming trend. Since the Industrial Era, human activities such as burning fossil fuels, deforestation, and agriculture have led to a significant increase in greenhouse gas emissions, causing a rapid warming of the Earth's atmosphere and oceans. The concentration of carbon dioxide in the atmosphere has risen by more than 40% since pre-industrial times, and the global average temperature has increased by approximately 1.1 degrees Celsius. The effects of climate change are already being felt around the world, with more frequent and severe heat waves, droughts, wildfires, storms, and floods, and the melting of glaciers and sea ice. The impacts are expected to worsen in the future, posing significant risks to human societies and ecosystems. To address the challenge of climate change, global action is required to reduce greenhouse gas emissions and transition to a low-carbon, sustainable future. This involves a range of measures, such as increasing renewable energy, improving energy efficiency, promoting sustainable land use practices, and building resilience to the impacts of climate change. Climate change across history in architecture. The impacts of climate change on architecture have been observed throughout history. In the past, architects and builders adapted to local climates and environments by using natural materials, designing buildings with appropriate orientation and ventilation, and incorporating features such as courtyards and shading devices to mitigate the effects of heat and sunlight. For example, in hot and dry regions such as the Middle East, traditional buildings often featured thick walls, small openings, and courtyards to provide shade and ventilation. In colder regions such as Scandinavia, buildings were designed with steep roofs and thick insulation to keep heat inside. However, with the rise of modern architecture and industrialization, buildings became more standardized and less responsive to local climatic conditions. Modernist architects often prioritized aesthetics and functional efficiency over considerations of climate and environment. In recent years, there has been a renewed interest in designing buildings that are responsive to climate change and sustainable. This involves incorporating passive design strategies such as optimizing building orientation, using natural ventilation and daylight, and incorporating shading devices to reduce energy consumption and improve thermal comfort. In addition, architects and builders are increasingly using sustainable and low-carbon materials, such as timber and bamboo, and incorporating renewable energy sources such as solar and wind power. The use of green roofs and walls is also becoming more common to mitigate the urban heat island effect and improve air quality. Overall, there is a growing recognition among architects and builders of the importance of designing buildings that are responsive to local climate and environment, and that contribute to the mitigation and adaptation to climate change. Causes of climate change. The primary cause of climate change is the increase in greenhouse gases in the Earth's atmosphere, particularly carbon dioxide, CO2, which is primarily produced by human activities. The following are some of the major causes of climate change. Burning fossil fuels. The burning of coal, oil, and natural gas for energy production releases large amounts of carbon dioxide and other greenhouse gases into the atmosphere, contributing to global warming. Deforestation. Trees absorb carbon dioxide from the atmosphere through photosynthesis. Deforestation reduces the number of trees available to absorb carbon dioxide, leading to higher levels of greenhouse gases in the atmosphere. Agricultural practices. Agriculture is a significant contributor to greenhouse gas emissions, with livestock farming, rice cultivation, and fertilizer use being major sources. Industrial processes. The production of cement, steel, and other materials involves the release of large amounts of carbon dioxide and other greenhouse gases. Transportation. The use of cars, trucks, and airplanes for transportation releases significant amounts of greenhouse gases, particularly carbon dioxide. Land use change. Activities such as urbanization, mining, and infrastructure development often involve the destruction of natural habitats and the release of greenhouse gases. Natural factors. Although human activities are the primary cause of climate change, natural factors such as volcanic activity, solar radiation, and changes in the Earth's orbit can also influence the Earth's climate. Overall, human activities are the main drivers of climate change, and reducing greenhouse gas emissions from these activities is essential to address the challenge of climate change. Anthropogenic drivers of climate change. Anthropogenic, or human-caused, drivers of climate change include a range of activities that release greenhouse gases into the atmosphere and alter the Earth's climate. The following are some of the main anthropogenic drivers of climate change. Burning fossil fuels. The burning of coal, oil, and natural gas for energy production is the largest contributor to greenhouse gas emissions, particularly carbon dioxide, CO2. Deforestation and other land use changes, such as clearing land for agriculture or urbanization, contribute to increased levels of CO2 in the atmosphere by reducing the number of trees that absorb CO2 through photosynthesis. Agriculture, livestock farming, rice cultivation, and the use of synthetic fertilizers in agriculture are all sources of greenhouse gas emissions, primarily methane and nitrous oxide. Industrial processes, the production of cement, steel, and other materials involve significant emissions of CO2. Transportation, the use of cars, trucks, and airplanes for transportation is a significant contributor to greenhouse gas emissions, primarily CO2. Waste management, landfills, and waste incineration facilities produce methane and other greenhouse gases. These anthropogenic drivers of climate change have led to an increase in the concentration of greenhouse gases in the atmosphere, which traps heat and leads to a warming of the Earth's surface and oceans. This warming has led to a range of impacts, including more frequent and severe heat waves, droughts, floods, storms, and the melting of glaciers and sea ice. To address the challenge of climate change, reducing greenhouse gas emissions from these activities is essential, along with efforts to transition to a low-carbon, sustainable future. Global warming, greenhouse effect, carbon stocks and flow, interaction of these factors at global and Indian scale. Global warming, the greenhouse effect, carbon stocks, and carbon flow are all interconnected factors that contribute to climate change. Here is an overview of how these factors interact at both global and Indian scales. Global scale. Global warming refers to the overall increase in temperature of the Earth's surface and oceans due to the increased concentration of greenhouse gases in the atmosphere, which trap heat and lead to warming. The greenhouse effect is the natural process by which greenhouse gases in the atmosphere, such as carbon dioxide, CO2, water vapor, and methane, trap heat and keep the Earth's temperature within a habitable range. Carbon stocks refer to the amount of carbon stored in various reservoirs on the Earth, such as the atmosphere, oceans, and land. The carbon cycle involves the flow of carbon between these reservoirs. The increased concentration of greenhouse gases, particularly CO2, in the atmosphere is primarily caused by human activities such as burning fossil fuels and deforestation, which disrupts the carbon cycle and increases carbon flow from the land to the atmosphere. Indian scale. India is particularly vulnerable to the impacts of global warming and climate change, as it has a vast and diverse landscape with many different climate zones. The impacts of global warming are already being felt in India, with increasing temperatures, changes in rainfall patterns, and more frequent extreme weather events such as floods and droughts. India has a significant carbon footprint, primarily driven by the burning of fossil fuels for energy and transportation, and the country is one of the world's largest emitters of greenhouse gases. At the same time, India has significant carbon stocks, particularly in its forests, which play a crucial role in mitigating climate change by absorbing and storing carbon. India has implemented a range of policies and initiatives to address climate change, including a commitment to increase its share of renewable energy, efforts to improve energy efficiency, and programs to promote afforestation and sustainable agriculture. Overall, the interaction of global warming, the greenhouse effect, carbon stocks, and carbon flow is complex and interrelated. Understanding these factors and their impacts is crucial for addressing the challenge of climate change, both at the global and national levels. Evidence of climate change. There is a wealth of evidence that shows that the Earth's climate is changing and that this change is largely driven by human activities. Some of the key lines of evidence include temperature records. Global surface temperatures have been consistently rising since the late 1800s. According to NASA, the 10 warmest years on record have occurred since 2005, with 2016 being the warmest on record. Ocean warming. The world's oceans are absorbing a significant amount of the heat that is trapped by greenhouse gases. The upper 700 meters of the ocean have warmed by about 0.3 degrees Fahrenheit since 1969, and the rate of ocean warming has been accelerating since the 1990s. Sea level rise. Sea levels have risen by about 8 inches, 21 centimeters, since 1880, with about 3 inches, 8 centimeters, of that rise occurring in the last 25 years. Melting glaciers and ice sheets. Glaciers and ice sheets around the world are melting at an accelerating rate, contributing to sea level rise. Arctic sea ice has also been shrinking rapidly in recent years. Changes in precipitation. Climate change is causing changes in precipitation patterns around the world, leading to more frequent and severe droughts, floods, and extreme weather events. Biological impacts. Climate change is also having a significant impact on the world's ecosystems and biodiversity. Many species are experiencing changes in their behavior, migration patterns, and distribution in response to changing temperatures and weather patterns. These lines of evidence, along with many others, provide strong support for the reality and urgency of climate change. It is important that we take action to mitigate the impacts of climate change and adapt to the changes that are already occurring. Climate change predictions at macro and micro level. Climate change predictions are made by using complex models that simulate the Earth's climate system and its response to changes in greenhouse gas concentrations, atmospheric conditions, and other factors. These models provide predictions at both macro and micro levels. Macro-level predictions. At the macro level, climate change predictions are made for the planet as a whole or for large regions such as continents. Some of the key predictions include temperature changes. Global temperatures are expected to continue to rise, with an increase of 2.5 to 10 degrees Fahrenheit by the end of the century, depending on the level of greenhouse gas emissions. Sea level rise. Sea levels are expected to continue to rise, with predictions ranging from 1 to 8 feet by the end of the century, depending on the rate of ice melt and other factors. Precipitation changes. Climate change is expected to lead to changes in precipitation patterns, with some regions experiencing more frequent and severe droughts, while others experience increased flooding. Extreme weather events. Climate change is expected to increase the frequency and severity of extreme weather events such as heat waves, hurricanes, and wildfires. Micro-level predictions. At the micro level, climate change predictions are made for specific regions or even individual cities. These predictions consider the local climate, topography, and other factors. Some of the key predictions include temperature changes. Local temperatures are expected to increase, with some regions experiencing greater warming than others due to factors such as urban heat islands or proximity to bodies of water. Precipitation changes. Climate change is expected to lead to changes in local precipitation patterns, with some regions experiencing more frequent and severe droughts, while others experience increased flooding. Sea level rise. Local sea levels are expected to rise, with some regions experiencing greater impacts than others due to factors such as local topography and land use. Ecological impacts. Climate change is expected to have significant impacts on local ecosystems, with some species experiencing changes in their behavior, migration patterns, and distribution in response to changing temperatures and weather patterns. Overall, climate change predictions provide valuable insights into the potential impacts of climate change at both macro and micro levels. It is important that we use these predictions to inform our efforts to mitigate and adapt to the impacts of climate change. Disaster vulnerability of India, with emphasis on climate change. India is one of the most disaster-prone countries in the world, with a wide range of natural and man-made disasters occurring regularly. Climate change is expected to exacerbate the vulnerability of the country to disasters in several ways. Some of the key vulnerabilities of India to climate change and related disasters are: floods. India is prone to frequent and severe flooding, particularly in low-lying areas and river basins. Climate change is expected to increase the frequency and intensity of extreme rainfall events, leading to more frequent and severe floods. Droughts. India is also prone to frequent and severe droughts, particularly in arid and semi-arid regions. Climate change is expected to exacerbate drought conditions, leading to reduced water availability and impacts on agriculture and food security. Heat waves. India is experiencing increasing frequency and severity of heat waves, particularly in urban areas. Climate change is expected to increase the frequency and intensity of extreme heat events, leading to significant health impacts and strain on infrastructure. Cyclones. India is prone to severe cyclones, particularly in coastal regions. Climate change is expected to increase the intensity and frequency of tropical cyclones, leading to more frequent and severe impacts on coastal communities. Landslides. India is also prone to frequent landslides, particularly in hilly and mountainous regions. Climate change is expected to increase the frequency and severity of landslides, leading to significant impacts on infrastructure and communities. Sea level rise. India has a long coastline and low-lying areas that are vulnerable to sea level rise. Climate change is expected to lead to rising sea levels, increasing the risk of coastal flooding and erosion. Overall, India's vulnerability to disasters related to climate change is significant and requires urgent action to mitigate and adapt to the impacts. The Indian government has implemented several initiatives and policies to address climate change and disaster management, but more needs to be done to build resilience and reduce vulnerability to these impacts. Unit 2. Adaptation to climate change. Its effects. Adaptation to climate change involves actions and strategies taken to minimize the negative impacts of climate change and to take advantage of any opportunities that arise. The effects of adaptation to climate change can be significant and wide-ranging, and can include: increased resilience. Adaptation measures can increase the resilience of communities and ecosystems to the impacts of climate change, making them better able to cope with and recover from extreme events. Improved food security. Adaptation measures can help to improve food security by increasing the productivity and resilience of agricultural systems, and by improving access to water and other resources. Enhanced water security. Adaptation measures can help to enhance water security by improving water management and storage systems, and by promoting sustainable water use practices. Reduced vulnerability. Adaptation measures can help to reduce the vulnerability of communities and ecosystems to the impacts of climate change, by reducing exposure and sensitivity to these impacts. Enhanced biodiversity. Adaptation measures can help to enhance biodiversity by promoting conservation and restoration of ecosystems, and by reducing the impact of human activities on natural systems. Increased economic opportunities. Adaptation measures can create new economic opportunities, such as through the development of new technologies, products, and services, and by promoting sustainable practices that are more resilient to climate change impacts. Overall, adaptation to climate change can have a range of positive effects, not just in terms of reducing vulnerability to climate change impacts, but also in terms of enhancing sustainability, promoting economic growth, and improving human well-being. Complexities and uncertainties rising out of climate change in built environment. Climate change presents complex and uncertain challenges for the built environment, which can pose significant risks and costs for individuals, communities, and economies. Some of the key complexities and uncertainties arising from climate change in the built environment are: uncertain future climate conditions. Climate change is expected to lead to a range of changes in weather patterns, such as increased frequency and intensity of extreme weather events, changes in precipitation patterns, and rising sea levels. However, the exact nature and extent of these changes are uncertain and may vary depending on the region and the time frame. Interconnected systems. The built environment is a complex system that is interconnected with other systems, such as transportation, energy, water, and waste management. Climate change impacts can have cascading effects on these systems, creating further complexities and uncertainties. Long lifespan of buildings and infrastructure. Buildings and infrastructure are designed to last for several decades or even centuries. Climate change impacts may be felt over long periods of time, which can make it difficult to anticipate and plan for future risks. Socioeconomic factors. Climate change impacts are not distributed evenly across society, with vulnerable communities and populations likely to be disproportionately affected. The complex social, economic, and political factors that shape vulnerability and resilience to climate change further add to the uncertainties and complexities in the built environment. Technological and institutional challenges. Adapting to climate change in the built environment requires significant technological and institutional changes, including changes in building codes, zoning laws, and infrastructure planning. These changes may be difficult to implement due to political, financial, and technical challenges. Overall, the complexities and uncertainties arising from climate change in the built environment require a multidisciplinary and adaptive approach to planning and decision-making. This includes integrating climate change considerations into building design, urban planning, and infrastructure development, and involving stakeholders and communities in the planning process. Climate adaptation, mitigation, and resilience related to climate change. Climate adaptation, mitigation, and resilience are all important strategies for addressing climate change and its impacts on the built environment. Climate adaptation involves taking actions to reduce vulnerability and increase resilience to the impacts of climate change. This can include measures such as improving building design to withstand extreme weather events, implementing flood protection measures, and developing drought-resistant agriculture. Climate mitigation involves taking actions to reduce greenhouse gas emissions and slow the rate of climate change. This can include measures such as promoting energy-efficient buildings, transitioning to renewable energy sources, and promoting sustainable transportation. Climate resilience involves building the capacity of communities and ecosystems to cope with and recover from the impacts of climate change. This can include measures such as developing early warning systems for extreme weather events, promoting sustainable land use practices, and improving emergency preparedness and response. In order to effectively address climate change, it is important to implement a combination of adaptation, mitigation, and resilience strategies. For example, while mitigation efforts may help to reduce the severity of climate change impacts over the long term, adaptation measures are needed to cope with the impacts that are already occurring or that are expected to occur soon. Resilience measures can also help to ensure that communities and ecosystems are able to bounce back from the impacts of climate change and to adapt to changing conditions over time. Overall, a holistic approach that integrates adaptation, mitigation, and resilience measures can help to reduce the risks and costs of climate change, while promoting sustainable and resilient built environments that can thrive in a changing climate. Adaptation to climate change, reactive and proactive measures. Adaptation to climate change can involve both reactive and proactive measures. Reactive measures are those that respond to existing or anticipated impacts of climate change, while proactive measures are those that aim to reduce vulnerability to future impacts of climate change. Reactive measures include emergency response planning and preparedness. This involves preparing for and responding to extreme weather events such as floods, hurricanes, and heat waves. Retrofitting of buildings and infrastructure. This involves making modifications to existing buildings and infrastructure to increase their resilience to the impacts of climate change, such as installing flood barriers or reinforcing roofs to withstand high winds. Relocation and resettlement. In some cases, relocation or resettlement may be necessary to protect people and communities from the impacts of climate change, such as sea level rise or increased risk of wildfires. Proactive measures include green infrastructure. This involves the use of natural systems such as parks, green roofs, and permeable pavements to mitigate the impacts of climate change, such as reducing urban heat island effects and managing stormwater runoff. Planning and zoning regulations. This involves designing communities and infrastructure to reduce vulnerability to climate change impacts, such as placing buildings and infrastructure in less vulnerable areas. Education and awareness raising. This involves increasing public awareness of climate change impacts and promoting actions that individuals can take to reduce their vulnerability to these impacts, such as reducing energy consumption or planting drought-resistant crops. Overall, a combination of reactive and proactive measures is needed to effectively adapt to the impacts of climate change. Reactive measures can help to address immediate threats and protect vulnerable populations, while proactive measures can help to reduce future risks and promote long-term resilience. Climate adaptation in contemporary architecture. Climate adaptation is an increasingly important consideration in contemporary architecture. Architects are designing buildings and infrastructure that are more resilient to the impacts of climate change, and that can help to reduce greenhouse gas emissions and slow the rate of climate change. Some examples of climate adaptation measures in contemporary architecture include passive design strategies. These involve designing buildings to minimize energy use and reduce reliance on mechanical heating and cooling systems. Passive strategies can include features such as natural ventilation, shading devices, and energy-efficient insulation. Green roofs and walls. These features can help to reduce urban heat island effects, improve air quality, and provide additional insulation to buildings. They can also help to manage stormwater runoff and reduce flooding. Flood-resistant design. This involves designing buildings and infrastructure to withstand flooding and other extreme weather events. Measures can include elevating buildings above flood levels, designing water-resistant foundations, and using flood-resistant materials. Sustainable materials. Architects are increasingly using sustainable materials in building design, such as recycled or locally sourced materials. This can help to reduce the environmental impact of construction and promote a more circular economy. Renewable energy systems. Incorporating renewable energy systems such as solar panels, wind turbines, or geothermal heating and cooling can help to reduce greenhouse gas emissions and promote sustainable energy use. Overall, climate adaptation is an important consideration in contemporary architecture, and architects are increasingly incorporating measures to reduce the vulnerability of buildings and infrastructure to the impacts of climate change. By designing buildings that are more resilient, architects can help to create sustainable and livable communities that can thrive in a changing climate. Need for sustainable measures in disaster mitigation. Sustainable measures are crucial for disaster mitigation because they can help to reduce the vulnerability of communities to the impacts of disasters, while also promoting long-term resilience and sustainability. Some reasons why sustainable measures are needed in disaster mitigation include: reduce environmental impacts. Traditional disaster mitigation measures, such as building levees or seawalls, can have significant environmental impacts. Sustainable measures, such as green infrastructure or ecosystem-based approaches, can help to reduce the environmental impact of disaster mitigation efforts. Promote community resilience. Sustainable measures can help to build community resilience by reducing vulnerability to the impacts of disasters and promoting sustainable practices that can help to mitigate future risks. Long-term cost savings. Sustainable measures can often be more cost-effective over the long term than traditional mitigation measures. For example, green infrastructure can provide multiple benefits, such as reducing flood risk, improving air quality, and enhancing urban aesthetics. Address underlying vulnerabilities. Sustainable measures can help to address underlying vulnerabilities that may contribute to the impacts of disasters, such as poverty, inadequate infrastructure, or lack of access to resources. Overall, sustainable measures are needed in disaster mitigation to promote long-term resilience, reduce environmental impacts, and address underlying vulnerabilities. By incorporating sustainable practices into disaster mitigation efforts, we can create more livable, sustainable, and resilient communities that can withstand the impacts of disasters and thrive in a changing climate. Changes in the ecosystem post-disaster due to climate change. Climate change can have significant impacts on ecosystems following a disaster. The severity of these impacts will depend on the specific type and scale of the disaster, as well as the vulnerability of the ecosystem to climate change. Here are some potential changes that may occur. Loss of biodiversity. Disasters can lead to the loss of species and reduced genetic diversity in ecosystems. Climate change can exacerbate this problem by changing the conditions that support the survival of certain species. Changes in plant and animal populations. Disasters can lead to changes in the abundance and distribution of plant and animal populations. For example, floods can displace animals and destroy habitats, while wildfires can reduce vegetation and impact the food chain. Alterations to soil quality. Disasters can also impact the quality of soil in an ecosystem. For example, flooding can deposit sediment and debris that can alter soil structure and nutrient availability. Increased vulnerability to invasive species. Disasters can create conditions that are favorable for invasive species to thrive. Climate change can exacerbate this problem by creating new opportunities for invasive species to establish themselves. Changes in ecosystem services. Disasters can impact the ability of ecosystems to provide important services such as carbon sequestration, water regulation, and nutrient cycling. Climate change can amplify these impacts by altering the conditions that support these services. Overall, the impacts of climate change on ecosystems following a disaster can be significant and far-reaching. It is important to consider these impacts when developing disaster preparedness and mitigation strategies, and to take measures to protect vulnerable ecosystems from further damage. Restoring ecological balance post-disaster due to climate change. Restoring ecological balance post-disaster due to climate change is a challenging and complex process that requires a coordinated effort from all stakeholders involved in the recovery and restoration process. Here are some key steps that can be taken to restore ecological balance. Assess the damage. A thorough assessment of the ecological damage caused by the disaster is essential to understand the extent of the damage and the type of restoration efforts needed. This will involve collecting data on the ecological conditions before and after the disaster and identifying the areas that are most affected. Prioritize restoration efforts. Based on the assessment, priority areas for restoration efforts can be identified. This may include areas that are critical for the survival of species, areas that are at high risk of erosion or other forms of degradation, or areas that provide important ecological services. Develop a restoration plan. A restoration plan should be developed that outlines the restoration goals, the strategies and techniques to be used, and the timeline and resources needed for the restoration efforts. This plan should involve the participation of all stakeholders, including local communities, NGOs, and government agencies. Implement restoration efforts. Once the restoration plan is in place, restoration efforts can begin. This may involve a range of techniques, such as reforestation, erosion control, habitat restoration, or the reintroduction of native species. Techniques such as green infrastructure, conservation agriculture, and agroforestry can be adopted to restore and maintain ecological balance. Monitor and evaluate progress. Regular monitoring and evaluation of the restoration efforts are essential to ensure that the restoration goals are being met and to identify any challenges or changes that may require adjustments to the restoration plan. Build resilience. In addition to restoration efforts, building resilience in the ecosystem is essential to prevent future disasters and ensure long-term sustainability. This may involve promoting sustainable practices, conserving biodiversity, improving soil health, and reducing greenhouse gas emissions. Overall, restoring ecological balance post-disaster due to climate change is a complex and long-term process that requires a coordinated effort from all stakeholders involved in the restoration process. By following these steps, we can promote the recovery of damaged ecosystems and build resilience to future disasters. Climate adaptation in architecture. Climate adaptation in architecture involves designing buildings and infrastructure that are resilient to the impacts of climate change, such as extreme temperatures, flooding, and storms. The following are some key strategies for climate adaptation in architecture. Passive design strategies. Passive design strategies involve designing buildings to take advantage of natural resources such as sunlight, wind, and vegetation to maintain comfortable indoor temperatures. This can include features such as shading devices, natural ventilation, and green roofs and walls. Building envelope. The building envelope is the physical barrier between the interior and exterior of a building. Improving the building envelope can help to reduce energy consumption by improving insulation, sealing air leaks, and using high-performance glazing. Water management. Climate change is expected to lead to more frequent and intense rainfall events, which can lead to flooding and water damage. Incorporating water management strategies such as green roofs, rain gardens, and permeable pavement can help to manage stormwater runoff and reduce the risk of flooding. Adaptation planning. Building designers and planners can work with communities and local governments to develop adaptation plans that address the specific risks and challenges posed by climate change. This can involve incorporating sea level rise projections into building design, identifying flood-prone areas, and developing emergency plans for extreme weather events. Sustainable materials and construction practices. Sustainable building materials and construction practices can help to reduce the carbon footprint of buildings and reduce their vulnerability to climate change impacts. This can include using locally sourced materials, using renewable energy sources, and minimizing waste during construction. Incorporating these strategies into building design and planning can help to create buildings and infrastructure that are resilient to the impacts of climate change and promote long-term sustainability and resilience. Relationship between nature and built form. Climate adaptation in architecture. The relationship between nature and built form is crucial in the design of buildings that are resilient to climate change. Buildings must be designed to respond to their local climate and natural environment to ensure they are comfortable, healthy, and energy efficient. Climate adaptation in architecture involves designing buildings that are responsive to local weather conditions and that work in harmony with the natural environment. Some key considerations for climate adaptation in architecture include site analysis. The site analysis involves studying the local climate, topography, soil conditions, and vegetation to determine the best location for a building and to identify any potential risks, such as flooding or high winds. Bioclimatic design. Bioclimatic design involves using passive design strategies to take advantage of natural resources such as sunlight, wind, and vegetation to maintain comfortable indoor temperatures. This can include features such as shading devices, natural ventilation, and green roofs and walls. Water management. Buildings must be designed to manage water resources sustainably, especially in regions with limited water resources. Incorporating water management strategies such as rainwater harvesting, gray water systems, and water-efficient fixtures can help to reduce water consumption and minimize the impact of droughts. Material selection. The materials used in construction have a significant impact on the environment and climate. Selecting sustainable building materials that are durable, energy efficient, and recyclable can help to reduce the carbon footprint of buildings and promote long-term sustainability. Building maintenance. building maintenance is an essential component of climate adaptation in architecture. Regular maintenance of building systems such as HVAC, plumbing, and electrical systems can help to ensure they are functioning efficiently and reduce the risk of system failures that can result in damage to the building and negative environmental impacts. By designing buildings that are responsive to their local climate and natural environment, architects can create buildings that are more sustainable, energy efficient, and resilient to the impacts of climate change. Response and adaptation of vernacular and traditional architecture to climatic conditions and effects of climate change. Vernacular and traditional architecture have evolved over centuries in response to local climatic conditions, using materials and techniques that are well suited to the local environment. These buildings were designed to provide comfort and protection from the elements, using natural resources and passive design strategies to maintain comfortable indoor temperatures. In many cases, traditional buildings are inherently resilient to the effects of climate change, as they were designed to withstand extreme weather conditions. For example, buildings in hot and dry regions often incorporate thick walls and small windows to reduce heat gain and provide insulation, while buildings in humid regions often have raised floors and large overhanging roofs to provide shade and ventilation. Traditional buildings also often incorporate sustainable design principles such as the use of locally sourced materials and passive cooling strategies, which can help to reduce the carbon footprint of the building and promote long-term sustainability. However, the rapid pace of urbanization and modernization in many regions has led to the abandonment of traditional building techniques in favor of modern construction methods, which can often be less sustainable and less resilient to the impacts of climate change. As a result, there is a growing interest in reviving traditional building techniques and incorporating them into modern architectural practice. Incorporating traditional building techniques and passive design strategies into modern architecture can help to create buildings that are more sustainable, energy efficient, and resilient to the impacts of climate change. For example, incorporating natural ventilation and shading devices, using locally sourced and sustainable building materials, and incorporating green roofs and walls can help to reduce energy consumption, promote biodiversity, and mitigate the effects of urban heat islands. Unit 3. Architecture. Mitigation of climate change. Mitigation of climate change refers to efforts to reduce or prevent greenhouse gas emissions, in order to limit the magnitude and extent of climate change. Mitigation measures can be taken in various sectors, including energy production, transportation, industry, agriculture, and forestry. Some examples of mitigation measures include renewable energy, shifting from fossil fuels to renewable energy sources such as solar, wind, hydropower, and geothermal energy can significantly reduce greenhouse gas emissions. Energy efficiency, improving the energy efficiency of buildings, appliances, and transportation can also help to reduce emissions. Carbon capture and storage, technologies that capture and store carbon dioxide emissions from power plants and industrial facilities can help to reduce emissions. Afforestation and reforestation, planting trees and restoring forests can help to sequester carbon dioxide from the atmosphere. Sustainable agriculture. Sustainable agriculture practices such as conservation tillage, crop rotation, and the use of organic fertilizers can reduce greenhouse gas emissions from agriculture. Sustainable transportation. Promoting the use of public transportation, electric vehicles, and cycling can reduce emissions from transportation. Mitigation measures are essential to limit the extent of climate change and avoid the most severe impacts. However, even with aggressive mitigation efforts, some degree of climate change is already locked in due to past emissions. Therefore, adaptation measures are also necessary to cope with the impacts of climate change that cannot be avoided. Climate change vulnerability analysis and assessment. Climate change vulnerability analysis and assessment involves identifying the susceptibility and resilience of communities, ecosystems, and infrastructure to the impacts of climate change. The process of vulnerability assessment typically involves four main steps. Identifying the exposure. The first step is to identify the areas, populations, and infrastructure that are exposed to the impacts of climate change. This may involve mapping the distribution of climate-sensitive ecosystems, such as coastal areas, wetlands, or forests, and identifying vulnerable populations, such as low-income communities or indigenous peoples. Assessing sensitivity. The next step is to assess the sensitivity of the identified areas, populations, and infrastructure to the potential impacts of climate change. Sensitivity can be influenced by a range of factors, such as geography, topography, ecology, infrastructure, and socioeconomic conditions. Analyzing adaptive capacity. The third step is to analyze the adaptive capacity of the identified areas, populations, and infrastructure to respond to the impacts of climate change. Adaptive capacity is the ability of systems to adjust and respond to changes in their environment. It can be influenced by factors such as governance structures, access to resources, technological capacity, and social networks. Integrating the results. The final step is to integrate the results of the exposure, sensitivity, and adaptive capacity analyses to identify areas of high vulnerability and prioritize interventions to reduce vulnerability and build resilience. Vulnerability assessment can help to identify areas that are most at risk from climate change and prioritize actions to reduce vulnerability and build resilience. It can also help to identify opportunities for adaptation and identify gaps in knowledge or data that need to be addressed. The results of vulnerability assessments can be used to inform decision-making in a range of sectors, including urban planning, agriculture, water management, and disaster risk reduction. Climate change social consequences. Climate change has a range of social consequences that are likely to have significant impacts on communities and societies around the world. Some of the key social consequences of climate change include displacement and migration. Climate change is expected to lead to more frequent and severe natural disasters, such as floods, storms, and droughts, which can displace people from their homes and communities. In addition, rising sea levels and coastal erosion may force people to relocate from vulnerable coastal areas. These displacement and migration trends can have significant social and economic consequences, as well as implications for the safety and well-being of affected populations. Health impacts. Climate change is likely to have significant impacts on human health, particularly through the spread of vector-borne diseases, such as malaria and dengue fever, and the increased frequency of extreme weather events, such as heat waves and floods. These health impacts are likely to disproportionately affect vulnerable populations, such as the elderly, children, and people living in poverty. Food security. Climate change is expected to have significant impacts on agricultural production, particularly in regions that are already experiencing food insecurity. Changes in temperature, rainfall patterns, and water availability are likely to reduce crop yields and increase food prices, which can have significant social and economic consequences, particularly for low-income populations. Social and economic inequality. Climate change is likely to exacerbate existing social and economic inequalities, particularly in developing countries. The impacts of climate change are likely to be felt most acutely by those who are already vulnerable or marginalized, such as women, children, and indigenous peoples. Conflict and political instability. Climate change may contribute to political instability and conflict, particularly in regions that are already experiencing social and economic stress. This may occur through competition for scarce resources, such as water and land, or through the displacement of people from their homes and communities. Overall, the social consequences of climate change are likely to be significant and far-reaching, with the potential to impact many aspects of human life, including health, food security, and political stability. Addressing these social consequences will require coordinated action at the global, regional, and local levels, including efforts to reduce greenhouse gas emissions, build resilience to the impacts of climate change, and support vulnerable populations. Climate change mitigation in buildings and urbanism. Buildings and urban areas are responsible for a significant proportion of global greenhouse gas emissions, and as such, reducing the carbon footprint of buildings and urban areas is an important component of climate change mitigation efforts. There are several strategies for mitigating the impacts of climate change in buildings and urbanism, including energy efficiency. One of the most effective ways to reduce greenhouse gas emissions from buildings is to improve their energy efficiency. This can be achieved through a range of measures, including building envelope improvements, more efficient HVAC systems, and the use of energy-efficient lighting and appliances. Renewable energy. Buildings can also reduce their carbon footprint by incorporating renewable energy sources, such as solar panels or wind turbines. This can help to reduce reliance on fossil fuels and can also provide a source of on-site energy. Green infrastructure. Urban areas can mitigate the impacts of climate change by incorporating green infrastructure, such as parks, green roofs, and green walls. These features can help to absorb carbon dioxide from the atmosphere and can also help to mitigate the impacts of extreme weather events, such as flooding and heat waves. Sustainable transportation. Urban areas can also reduce their carbon footprint by promoting sustainable transportation options, such as cycling, walking, and public transportation. This can help to reduce reliance on private vehicles and can also help to reduce emissions from transportation. Smart growth and compact development. Compact, walkable urban areas can also help to mitigate the impacts of climate change by reducing the need for private vehicles and promoting sustainable transportation options. This can also help to reduce emissions from transportation and can help to promote more sustainable patterns of development. Overall, there are many strategies for mitigating the impacts of climate change in buildings and urbanism, and it is important to take a comprehensive approach that addresses the full range of factors that contribute to greenhouse gas emissions in these sectors. By taking action to reduce emissions, promote renewable energy, and promote sustainable patterns of development, buildings and urban areas can play an important role in mitigating the impacts of climate change. Mitigation from demand and supply side mitigation. Mitigation from demand and supply side are two complementary approaches to reduce greenhouse gas (GHG) emissions and mitigate the effects of climate change. Demand-side mitigation refers to reducing the demand for goods and services that result in GHG emissions. This can be achieved through various strategies such as energy conservation, reducing energy consumption in households, commercial and industrial buildings, and transportation through energy-efficient technologies, practices, and behavior change. Lifestyle changes, adopting low-carbon lifestyles by reducing consumption, reusing and recycling materials, using public transportation or walking, and reducing meat consumption. Sustainable urban planning, promoting compact and transit-oriented urban development, reducing urban sprawl, and improving public transportation. On the other hand, supply-side mitigation involves reducing GHG emissions from the production and supply of goods and services. Some strategies include low-carbon energy sources, shifting from fossil fuels to renewable energy sources such as solar, wind, hydro, and geothermal power. Carbon capture and storage (CCS), capturing carbon dioxide emissions from power plants and industrial processes and storing them underground or using them for enhanced oil recovery. Sustainable agriculture, promoting practices that reduce GHG emissions, such as reducing livestock production, minimizing fertilizer use, and promoting agroforestry and conservation agriculture. Sustainable forestry, reducing deforestation and promoting reforestation and afforestation to enhance carbon sequestration. Both demand and supply-side mitigation strategies are important for achieving significant GHG emissions reductions and mitigating the effects of climate change. It is necessary to implement a mix of both approaches in order to effectively reduce GHG emissions and promote sustainable development. Climate change service demand reduction. Service demand reduction, SDR, is a type of demand-side mitigation strategy that aims to reduce the demand for energy and resources that contribute to climate change. SDR focuses on reducing the demand for services, such as transportation, heating and cooling, and lighting, rather than reducing the supply of energy or resources. Some examples of SDR strategies include energy-efficient buildings, constructing or retrofitting buildings with high-efficiency HVAC systems, insulation, and lighting systems. Low-carbon transportation, encouraging public transit, biking, and walking through urban planning and infrastructure investments. Smart grid technologies, implementing demand response programs and other smart grid technologies to reduce peak energy demand. Behavioral change programs, promoting energy-efficient behaviors, such as turning off lights when not in use, reducing water consumption, and reducing waste. Green procurement policies, promoting the use of energy-efficient and low-carbon products and services through procurement policies in the public and private sector. SDR strategies can be implemented at the individual, community, and institutional levels. They are important for reducing GHG emissions and mitigating the effects of climate change, as they help to reduce the demand for energy and resources, which ultimately reduces the carbon footprint of societies. Climate change carbon trading. Carbon trading, also known as emissions trading, is a market-based mechanism for mitigating climate change. It is a system where countries or companies can buy and sell permits or credits that represent a certain amount of carbon dioxide, CO2, emissions. Under the carbon trading system, countries or companies that emit less CO2 than their allocated limit can sell their unused emissions permits to countries or companies that exceed their limit. This creates an economic incentive for reducing emissions, as companies that can reduce their emissions below their allocated limit can generate revenue by selling their unused permits. Carbon trading operates under two main systems, cap-and-trade and baseline-and-credit. Under cap-and-trade, governments set a limit or cap on total emissions within a certain sector or industry. Companies that exceed their allocated emissions limit can purchase permits from companies that have reduced their emissions below their allocated limit. Baseline and credit systems, on the other hand, establish a baseline of emissions for a particular industry, and companies can earn credits for reducing emissions below that baseline. Carbon trading is seen as a cost-effective way to reduce GHG emissions, as it provides economic incentives for companies to reduce emissions, rather than imposing direct regulations or taxes. However, critics argue that carbon trading can allow companies to continue emitting GHGs without actually reducing their emissions, and that the effectiveness of the system depends on the accuracy of emissions monitoring and reporting. Mitigation strategies, carbon efficiency, reduction of building-related emissions. Mitigation strategies for reducing building-related emissions typically focus on two main areas: improving carbon efficiency and reducing energy consumption. Improving carbon efficiency involves reducing the amount of carbon emitted per unit of energy consumed. This can be achieved through a variety of measures, such as using more efficient heating, ventilation, and air conditioning, HVAC, systems, improving insulation and air sealing, using energy-efficient lighting, and incorporating renewable energy sources such as solar panels. Reducing energy consumption involves implementing measures to decrease overall energy use in buildings. This can include simple changes such as turning off lights and electronics when not in use, as well as more advanced strategies such as implementing energy management systems, using energy-efficient appliances and equipment, and optimizing building design to maximize natural lighting and ventilation. Other strategies for reducing building-related emissions include efficiency HVAC systems, insulation, and lighting systems. Using sustainable building materials that have a lower embodied carbon footprint. Implementing green roofs and walls to reduce the urban heat island effect and improve energy efficiency. Encouraging active transportation options such as biking, walking, and public transit to reduce emissions from transportation. Implementing water-saving measures to reduce energy consumption associated with water treatment and distribution. Overall, reducing building-related emissions requires a combination of measures that address both carbon efficiency and energy consumption, as well as considering the impact of building materials and transportation options. Case studies international mechanisms to support climate change mitigation and low-carbon development. There are several international mechanisms and initiatives aimed at supporting climate change mitigation and low-carbon development. Here are a few examples. Paris Agreement. The Paris Agreement is an international treaty signed in 2015 that aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit warming to 1.5 degrees Celsius. The agreement calls for each country to set nationally determined contributions, NDCs, to reduce greenhouse gas emissions and to regularly report on their progress. Clean Development Mechanism, CDM. The CDM is a project-based mechanism under the United Nations Framework Convention on Climate Change, UNFCCC, that allows developed countries to earn credits by investing in emissions reduction projects in developing countries. These credits can then be used to meet their own emissions reduction targets. REDD+, reducing emissions from deforestation and forest degradation. REDD+ is an international initiative aimed at reducing greenhouse gas emissions from deforestation and forest degradation and promoting sustainable forest management. The initiative provides financial incentives for developing countries to reduce emissions from deforestation and forest degradation, and to conserve and enhance forest carbon stocks. Green Climate Fund, GCF. The GCF is a fund established under the UNFCCC to support developing countries in their efforts to mitigate and adapt to climate change. The fund provides financing for low-emission and climate-resilient development projects, as well as capacity building and technical assistance. Climate Technology Center and Network, CTCN. The CTCN is a UNFCCC-supported initiative that promotes the transfer of climate-friendly technologies to developing countries. The center provides technical assistance and support to developing countries to help them identify, assess, and adopt appropriate technologies to mitigate and adapt to climate change. Case studies of successful implementation of these initiatives can be found across the world, such as in Costa Rica's efforts to reduce emissions from deforestation through the implementation of a national payment for ecosystem services program, or China's development of a national carbon trading system. Additionally, many cities and businesses have also taken action to reduce their carbon emissions and promote low-carbon development. Elaborate with case studies international mechanisms to support climate change mitigation and low-carbon development. There are various international mechanisms in place to support climate change mitigation and low-carbon development. Here are some case studies that highlight the impact of these mechanisms. Clean Development Mechanism, CDM. The CDM is a mechanism under the United Nations Framework Convention on Climate Change, UNFCCC, that allows developed countries to meet their emission reduction targets by investing in low-carbon projects in developing countries. One example of a successful CDM project is the Gansu Wind Farm project in China, which involved the installation of 33 wind turbines with a total capacity of 49.5 megawatts. This project reduced greenhouse gas emissions by approximately 118,000 tons per year and created job opportunities in the local community. Renewable Energy Certificates, RECs. RECs are tradable certificates that represent the environmental attributes of renewable energy generation. They are often used as a means of supporting the development of renewable energy projects. In India, the government has implemented a renewable purchase obligation, RPO, scheme that mandates power distribution companies to source a certain percentage of their electricity from renewable sources. To comply with the RPO, companies can either generate their own renewable energy or purchase RECs from renewable energy projects. The REC mechanism has helped to support the growth of the renewable energy sector in India. Nationally Appropriate Mitigation Actions, NAMAs. NAMAs are a mechanism under the UNFCCC that allows developing countries to receive support for their climate change mitigation efforts. One example of a successful NAMA project is the Green Affordable Housing Project in South Africa, which involved the construction of 2,000 energy-efficient houses for low-income families. The project reduced greenhouse gas emissions by approximately 27,000 tons per year and also provided affordable housing for disadvantaged communities. Green Climate Fund (GCF). The GCF is a fund established under the UNFCCC to support developing countries in their efforts to mitigate and adapt to climate change. One example of a successful GCF project is the Renewable Energy-Based Microgrids project in India, which involved the installation of renewable energy-based microgrids in 25 remote villages. The project provided access to clean energy for approximately 5,000 households and also created job opportunities in the local community. These case studies demonstrate the effectiveness of international mechanisms in supporting climate change mitigation and low-carbon development. By providing financial and technical support to developing countries, these mechanisms can help to accelerate the transition to a low-carbon economy and reduce the impacts of climate change. Elaborate with case studies and examples in architecture international mechanisms to support climate change mitigation and low-carbon development. There are several international mechanisms and programs aimed at supporting climate change mitigation and low-carbon development in the field of architecture. Here are some examples. Leadership in Energy and Environmental Design. LEED is a green building certification program developed by the U.S. Green Building Council, USGBC, to promote sustainability in building design, construction, and operation. It provides a framework for assessing the environmental performance of buildings across several categories such as water efficiency, energy and atmosphere, materials and resources, and indoor environmental quality. LEED certification is recognized internationally and has been adopted in several countries, including India, where it has been used in the design of several sustainable buildings, such as Infosys Mysuru campus and the Suslan One Earth campus. Building Research Establishment Environmental Assessment Method. BREEAM is a similar green building certification program developed in the UK. It assesses the sustainability performance of buildings across several categories, such as energy, water, materials, and waste. BREEAM certification is recognized internationally and has been used in the design of several sustainable buildings, such as the Crystal in London and the Parkview Green in Beijing. Passive House. Passive House is a building standard developed in Germany that focuses on energy efficiency in buildings by minimizing the need for heating and cooling. Passive house buildings are designed to be airtight and well insulated, with minimal thermal bridges, and to make use of passive solar gain and natural ventilation. Several passive house projects have been built around the world, including the Energiehaus Arlberg in Austria and the Tynoch Croit in Scotland. C40 Cities. C40 Cities is a network of over 90 cities around the world committed to tackling climate change. The network provides a platform for cities to share knowledge, resources, and best practices for reducing greenhouse gas emissions and adapting to the impacts of climate change. The network has several initiatives aimed at promoting sustainable architecture and urban development, such as the Clean Construction Declaration, which calls on the construction industry to reduce its carbon footprint and adopt sustainable building practices. United Nations Framework Convention on Climate Change, UNFCCC. The UNFCCC is an international treaty aimed at preventing dangerous human interference with the climate system. It has several mechanisms to support climate change mitigation and low-carbon development, such as the Clean Development Mechanism (CDM), which allows developed countries to invest in greenhouse gas reduction projects in developing countries and receive carbon credits in return. The UNFCCC also organizes the Conference of Parties, COP, an annual meeting of countries to discuss and negotiate global climate policy. These are just a few examples of international mechanisms and programs aimed at supporting climate change mitigation and low-carbon development in architecture. They provide a framework for sustainable building design and operation and promote the adoption of sustainable building practices around the world. Unit 4. Climate Change and Resilient Architecture. Climate change and resilient architecture are closely linked. Resilient architecture refers to the design and construction of buildings that can withstand extreme weather events and other environmental stresses. Climate change, with its increasing frequency and intensity of extreme weather events such as storms, floods, and heat waves, has made resilient architecture an essential aspect of sustainable design. There are several strategies and design considerations that architects and builders can incorporate into their projects to make them more resilient to the effects of climate change. Some of these include site selection and planning, choosing a site that is less vulnerable to natural disasters such as floods, landslides, and wildfires, and designing buildings to be oriented to take advantage of natural resources such as sunlight and wind. Building envelope design, designing building envelopes to be energy efficient, durable, and resistant to damage from wind, rain, and other extreme weather events. Water management, designing buildings to capture and reuse rainwater and incorporating strategies to reduce water usage. Passive design strategies, incorporating passive design strategies such as natural ventilation and daylighting to reduce energy consumption and increase indoor air quality. Material selection, choosing materials that are durable, sustainable, and have a low environmental impact. Several examples of resilient architecture in response to climate change can be found around the world. One such example is the Red Cross Climate Center in the Netherlands, which is designed to withstand extreme weather events such as floods and heat waves. The building is elevated to avoid flooding, and the roof is covered with a layer of vegetation to provide insulation and reduce heat gain. Another example is the One Bryant Park building in New York City, which incorporates a green roof and a rainwater harvesting system to reduce its environmental impact. Overall, resilient architecture is an important aspect of climate change mitigation and adaptation, and architects and builders must consider these strategies when designing and constructing buildings to ensure their longevity and sustainability in a changing climate. Architectural responses to impact of climate change. Architectural responses to the impact of climate change can be broadly categorized into three areas: adaptation, mitigation, and resilience. Adaptation focuses on designing buildings and cities that can respond to the changing climate conditions. This includes strategies such as using passive design techniques like shading, natural ventilation, and thermal mass to regulate indoor temperatures without relying on mechanical systems. It also involves incorporating green roofs and walls, rainwater harvesting, and other sustainable features that can help mitigate the effects of extreme weather events. Mitigation strategies, on the other hand, focus on reducing the carbon footprint of buildings and cities. This includes designing buildings with energy-efficient systems and materials, using renewable energy sources, and implementing waste reduction and recycling programs. Resilience involves designing buildings and cities that can withstand and recover from the impacts of extreme weather events. This includes strategies such as building stronger structures, using durable materials, and implementing emergency response plans. Examples of architectural responses to the impact of climate change include the Bullitt Center in Seattle, USA, which is designed to be a net-zero energy building that generates as much energy as it uses. The building features solar panels, rainwater harvesting, and a green roof. The Beddington Zero Energy Development, BEDS-ED, in the UK, which is a sustainable community designed to reduce energy consumption and carbon emissions. The development includes a range of sustainable features such as solar panels, wind turbines, and a combined heat and power plant. The Copenhagen Waste-to-Energy plant in Copenhagen, Denmark, which is designed to be both an energy source and a recreational space. The building features a ski slope on the roof and a hiking trail on the facade. The Singapore Sports Hub, which features a sustainable design that includes rainwater harvesting, solar shading, and natural ventilation. The building also includes a system that recycles waste heat from the swimming pool to heat the rest of the building. These examples demonstrate how architectural responses to the impact of climate change can be innovative and aesthetically pleasing while also being environmentally sustainable and resilient. Concept of climate resilience. Components and action for resilient built forms. Climate resilience refers to the capacity of built environments to adapt and cope with the adverse effects of climate change while maintaining essential functions and structures. It involves designing buildings and infrastructure in a way that is able to withstand and recover from extreme weather events and other climate-related challenges. The components and actions for resilient built forms can include building envelope design. This involves designing buildings to minimize exposure to extreme weather events such as floods, hurricanes, and wildfires. The building envelope should be able to withstand high winds, heavy rain, and other impacts. Energy-efficient design. Energy-efficient buildings consume less energy and are less vulnerable to power outages during extreme weather events. Incorporating features such as insulation, energy-efficient lighting, and solar panels can increase the resilience of the built environment. Water management. With climate change comes increased variability in water supply and quality. Building resilience can be achieved through the implementation of measures such as water-efficient landscaping, stormwater management, and water reuse systems. Adaptation of materials. Using materials that are durable and resistant to extreme weather events can help make buildings more resilient. For example, incorporating materials that can withstand flooding or high winds can help reduce damage and improve recovery times. Emergency preparedness. Building resilience also involves planning for emergencies and ensuring that critical systems such as power and water are able to withstand extreme weather events. This can include the installation of backup generators and the implementation of emergency response plans. Examples of resilient architecture can be found around the world. One such example is the hurricane-resistant home in Florida, USA, which was designed to withstand hurricane-force winds and flooding. The house was built on stilts to elevate it above flood levels and incorporated features such as hurricane-resistant windows and doors. Another example is the floating village in Cambodia, which was designed to adapt to the increasing risk of flooding due to climate change. The village is built on a network of floating structures and is designed to rise and fall with changes in water levels. In summary, building resilience in the face of climate change involves designing buildings and infrastructure to withstand extreme weather events and other climate-related challenges. This can be achieved through a combination of building envelope design, energy-efficient design, water management, adaptation of materials, and emergency preparedness. Planning strategies, methods, and tools for resilient architecture at various scales reacting to earthquakes, floods, cyclones, storms, temperature, etc. Resilient architecture is about designing buildings that can withstand and recover from the impacts of natural disasters and other climate-related events. Planning strategies, methods, and tools play a crucial role in achieving resilience in architecture. Some of the key strategies for resilient architecture at various scales are as follows. Regional scale. At the regional scale, land use planning is a crucial tool for ensuring resilience in architecture. Regional land use plans can take into account the risks associated with natural disasters and other climate-related events and identify areas that are less vulnerable to such risks. This can help in reducing the impact of disasters on the built environment. Urban scale. At the urban scale, urban design and planning can help in achieving resilience in architecture. For example, designing streets that can double up as waterways during floods can help in minimizing the impact of floods on the built environment. Similarly, designing buildings with green roofs and walls can help in reducing the heat island effect in cities, which can contribute to the resilience of the built environment. Building scale. At the building scale, building design and construction techniques are crucial for achieving resilience in architecture. For example, designing buildings with strong and flexible structures can help in minimizing the damage caused by earthquakes and other natural disasters. Similarly, using materials that can withstand high winds and heavy rainfall can help in achieving resilience in the face of storms and cyclones. Interior scale. At the interior scale, building systems such as HVAC, heating, ventilation, and air conditioning can play a key role in achieving resilience in architecture. For example, designing HVAC systems that can operate independently of the power grid can help in ensuring that buildings remain habitable during power outages caused by natural disasters. Tools for achieving resilience in architecture include risk assessment tools, such as hazard maps and vulnerability assessments, as well as building performance simulation tools, such as energy modeling and daylighting analysis. These tools can help architects and planners make informed decisions about building design and construction and ensure that buildings are resilient in the face of natural disasters and other climate-related events. Resilient backup and power systems. Resilient backup and power systems are essential components of resilient architecture, particularly in the face of climate change-related extreme weather events such as storms, floods, and heat waves. These systems help to ensure that critical infrastructure and services remain operational during power outages or other disruptions. There are several types of backup and power systems that can enhance the resilience of buildings and communities. Emergency generators. These are backup power systems that can be activated in the event of a power outage. Emergency generators are typically fueled by diesel, natural gas, or propane, and can provide power to critical systems such as lighting, elevators, and heating and cooling systems. Battery storage systems. Battery storage systems can store excess energy generated by solar panels or other renewable energy sources and provide backup power during outages. These systems can also help to reduce peak energy demand and lower electricity costs. Microgrids. Microgrids are self-contained, localized power grids that can operate independently of the main power grid. They typically incorporate renewable energy sources such as solar or wind power and can be used to power critical infrastructure and services during power outages. Passive design strategies. Passive design strategies can help to reduce energy demand and improve the resilience of buildings. For example, buildings can be designed to maximize natural ventilation and daylighting, which can reduce the need for mechanical systems and enhance indoor comfort during power outages. Energy-efficient systems and appliances. Energy-efficient systems and appliances can help to reduce energy demand and improve the resilience of buildings. For example, high-efficiency HVAC systems, lighting, and appliances can reduce energy demand and help to maintain indoor comfort during power outages. Overall, resilient backup and power systems are an important component of resilient architecture and can help to ensure that critical infrastructure and services remain operational during power outages or other disruptions. Climate change planning strategies. Climate change planning strategies involve the development of policies, plans, and programs to mitigate the impact of climate change on the built environment and communities. Some of the common planning strategies used in climate change adaptation and mitigation include land use planning. Land use planning involves the regulation of land use and development in a way that minimizes the impact of climate change. This can include the preservation of natural areas, the promotion of compact, mixed-use development patterns, and the development of green infrastructure. Green infrastructure. Green infrastructure involves the use of natural systems such as trees, wetlands, and open spaces to mitigate the impact of climate change. This can include the creation of green roofs and walls, the establishment of urban forests, and the development of parks and open spaces. Energy efficiency. Energy efficiency involves the reduction of energy consumption in buildings and other infrastructure to mitigate the impact of climate change. This can include the use of energy-efficient building designs, the installation of renewable energy systems, and the promotion of energy conservation practices. Water management. Water management involves the development of systems to manage water resources in a way that minimizes the impact of climate change. This can include the development of water-efficient technologies, the installation of stormwater management systems, and the establishment of green infrastructure to capture and retain stormwater. Disaster preparedness. Disaster preparedness involves the development of plans and programs to prepare communities for the impacts of climate change-related disasters such as floods, hurricanes, and wildfires. This can include the establishment of emergency response plans, the development of early warning systems, and the creation of evacuation plans. Examples of planning strategies at different scales include: city level. The city of Copenhagen, Denmark, has developed a comprehensive climate adaptation plan that includes the establishment of green roofs, the creation of new parks and open spaces, and the development of new stormwater management systems. Regional level. The state of California has developed a comprehensive climate change adaptation strategy that includes the establishment of new green infrastructure, the promotion of energy efficiency, and the development of new water management systems. National level. The government of the Netherlands has developed a comprehensive climate change adaptation strategy that includes the development of new flood protection systems, the establishment of new green infrastructure, and the creation of new water management programs. Methods and tools for resilient architecture at various scales reacting to earthquakes, floods, cyclones, storms, temperature, etc. Resilient architecture can be achieved through the use of various planning strategies, methods, and tools that aim to address the specific challenges posed by different types of climate change impacts. Some examples of these strategies, methods, and tools are: site analysis. Before designing a building, it is important to conduct a thorough analysis of the site, including its topography, soil conditions, wind patterns, and flood risk. This information can be used to inform the design of the building and its orientation, as well as the selection of materials and construction techniques. Building envelope. The building envelope is the physical barrier between the interior and exterior of a building, and it plays a critical role in protecting the occupants from the elements. A resilient building envelope should be designed to withstand the impact of extreme weather events, such as high winds and heavy rain, while also providing insulation to maintain comfortable indoor temperatures. Structural design. The structural design of a building should be able to withstand the forces exerted by earthquakes, cyclones, and other natural disasters. This can be achieved through the use of reinforced concrete, steel, or other materials that have high strength and durability. Landscaping. Landscaping can be used to mitigate the impact of extreme weather events, such as flooding and high winds. For example, the use of green roofs and permeable paving can help to reduce stormwater runoff and prevent flooding. Passive design strategies. Passive design strategies are techniques that do not require mechanical systems to regulate temperature and airflow in a building. Examples include the use of natural ventilation, shading, and thermal mass to maintain comfortable indoor temperatures. Renewable energy systems. Renewable energy systems, such as solar panels and wind turbines, can be used to generate electricity and reduce reliance on fossil fuels. These systems can also provide backup power during blackouts and other emergencies. Water management. Water management is an important consideration in resilient architecture, particularly in areas that are prone to flooding or drought. Techniques such as rainwater harvesting, and gray water reuse can be used to reduce water consumption and protect against water shortages. Building codes and regulations. Building codes and regulations play an important role in ensuring that buildings are designed and constructed to withstand the impact of climate change. Governments can develop and enforce codes that require buildings to meet certain resilience standards, such as the ability to withstand high winds and flooding. Overall, resilient architecture requires a multidisciplinary approach that takes into account the specific climate change impacts in a given region, as well as the needs and priorities of the local community. Climate change lighting services during emergency. During emergencies, it is crucial to have reliable and efficient lighting services to ensure safety and security. In the context of climate change, extreme weather events such as storms, floods, and cyclones can disrupt electricity supply and cause power outages. This can further exacerbate the emergency situation and increase risks to human life. To address this issue, there are several lighting solutions that can be employed to provide resilient lighting services during emergencies. Solar-powered lighting. Solar-powered lighting systems use solar panels to generate electricity, which can then be stored in batteries for use during emergencies. These systems are self-sufficient and do not require grid electricity, making them ideal for use during power outages. Portable lighting. Portable lighting systems, such as battery-operated lanterns and flashlights, can provide temporary lighting during emergencies. These systems are easy to carry and can be moved around to different locations as needed. Emergency lighting systems. Emergency lighting systems are designed to automatically switch on during power outages or emergencies. These systems are usually installed in public buildings such as hospitals, schools, and government offices. Hybrid lighting systems. Hybrid lighting systems combine multiple lighting technologies, such as solar-powered and grid-powered lighting, to provide reliable and resilient lighting services during emergencies. In addition to these solutions, it is important to have a backup plan in place in case of lighting system failure. This can include having extra batteries or fuel for portable lighting systems or having a generator on standby to provide backup power. Climate change resilient HVAC, water, stormwater, and gray water systems. Resilient HVAC, heating, ventilation, and air conditioning, water, stormwater, and gray water systems are critical components of resilient architecture. These systems can help mitigate the impacts of climate change and ensure that buildings are able to function even in the face of extreme weather events. Resilient HVAC systems may include features such as energy-efficient heating and cooling systems, air filtration and purification systems, and backup power sources. These systems can help ensure that buildings remain habitable and comfortable even during power outages or other disruptions. Resilient water systems may include features such as rainwater harvesting and greywater recycling systems, which can help reduce demand on municipal water supplies and ensure that buildings are able to access water even during periods of drought or other water scarcity events. Stormwater management systems may also be included to help reduce the risk of flooding and water damage to buildings. In addition to these systems, resilient architecture may also include features such as green roofs and walls, which can help mitigate the impacts of urban heat islands and provide additional insulation and cooling benefits. Other features may include shading devices, natural ventilation systems, and energy-efficient lighting and appliances. Overall, resilient HVAC, water, stormwater, and greywater systems are critical components of climate change resilience in architecture, helping to ensure that buildings are able to withstand and adapt to the impacts of a changing climate while continuing to provide safe and comfortable living and working spaces for their occupants. Unit 5. Legal frameworks, codes, and policies, strategies. Legal frameworks, codes, policies, and strategies play a crucial role in addressing climate change and promoting sustainable development. Here are some examples. International agreements. The United Nations Framework Convention on Climate Change, UNFCCC, is a treaty signed by 197 countries aimed at reducing greenhouse gas emissions and addressing climate change. The Paris Agreement, signed in 2015, is an extension of the UNFCCC, which aims to limit the global temperature increase to well below 2 degrees Celsius above pre-industrial levels. National policies. Many countries have developed national policies and strategies to address climate change. For example, India has developed the National Action Plan on Climate Change, NAPCC, which includes 8 missions focused on energy efficiency, renewable energy, sustainable habitat, and water conservation. Building codes and standards. Building codes and standards can help reduce the carbon footprint of buildings and promote sustainable design. For example, the Leadership in Energy and Environmental Design (LEED) certification system developed by the U.S. Green Building Council provides a framework for building owners and operators to measure and improve the environmental performance of their buildings. Energy codes and standards. Energy codes and standards set minimum requirements for energy efficiency in buildings and appliances. For example, the International Energy Conservation Code, IECC, is a model energy code that is adopted by many U.S. states and localities. Green procurement policies. Governments can promote sustainable practices by adopting green procurement policies, which require government agencies to purchase goods and services that meet certain environmental criteria. For example, the U.S. Environmental Protection Agency's (EPA) Environmentally Preferable Purchasing Program encourages federal agencies to purchase products and services that have a reduced impact on human health and the environment. Carbon pricing. Carbon pricing is a policy tool that puts a price on greenhouse gas emissions to incentivize reduction. For example, the European Union's emissions trading system (EU ETS) is a cap-and-trade system that sets a cap on greenhouse gas emissions for participating companies and allows them to trade emissions permits. Overall, legal frameworks, codes, policies, and strategies are essential tools for promoting sustainable development and addressing the challenges of climate change. Climate change initiatives at international level and participating bodies. There are several international initiatives and participating bodies working towards addressing climate change. Some of the major ones are United Nations Framework Convention on Climate Change, UNFCCC, established in 1992. The UNFCCC is an international treaty aimed at preventing dangerous anthropogenic interference with the climate system. It provides a framework for countries to cooperate on climate change mitigation, adaptation, and finance. Intergovernmental Panel on Climate Change, IPCC, established in 1988 by the World Meteorological Organization, WMO, and the United Nations Environment Programme, UNEP. The IPCC is a scientific body that provides policymakers with regular assessments of the scientific basis of climate change, its impacts, and future risks, as well as options for adaptation and mitigation. Paris Agreement. Adopted in 2015 under the UNFCCC, the Paris Agreement is a legally binding treaty that aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius. The agreement requires countries to submit nationally determined contributions, NDCs, outlining their climate change mitigation and adaptation efforts. Kyoto Protocol. Adopted in 1997 under the UNFCCC, the Kyoto Protocol is an international treaty that sets binding targets for industrialized countries to reduce their greenhouse gas emissions. The protocol was replaced by the Paris Agreement, but it remains an important milestone in international efforts to address climate change. Green Climate Fund, GCF, established under the UNFCCC in 2010, the GCF is a financial mechanism that aims to support climate change mitigation and adaptation in developing countries. It is the largest climate fund in the world, and it is funded by contributions from developed countries. Clean Development Mechanism, CDM, established under the Kyoto Protocol. The CDM is a market-based mechanism that allows developed countries to offset their greenhouse gas emissions by investing in emissions reduction projects in developing countries. World Bank Climate Change Action Plan. The World Bank is a global financial institution that provides loans and grants to developing countries. Its Climate Change Action Plan outlines the bank's efforts to support climate change mitigation and adaptation, including through the provision of financing for renewable energy projects and climate-smart agriculture. These initiatives and participating bodies play a crucial role in addressing climate change at the international level, and in supporting countries in their efforts to mitigate and adapt to the impacts of climate change. Climate change initiatives at international level and participating bodies. Goals, objectives, challenges. There are numerous climate change initiatives at the international level, with various participating bodies and organizations. Some of the key initiatives include United Nations Framework Convention on Climate Change, UNFCCC. This is an international treaty signed by 197 countries with the goal of stabilizing greenhouse gas concentrations in the atmosphere. Paris Agreement. This agreement was signed in 2015 under the UNFCCC and aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels, with a goal of 1.5 degrees Celsius. Intergovernmental Panel on Climate Change, IPCC. This is a scientific body under the auspices of the UN that assesses the science related to climate change, its impacts, and options for adaptation and mitigation. Global Climate Action Summit. This is an initiative led by the United Nations Secretary-General to bring together leaders from government, business, and civil society to accelerate climate action. Climate and Clean Air Coalition, CCAC. This is a voluntary global partnership of governments, international organizations, businesses, scientific institutions, and civil society organizations committed to reducing short-lived climate pollutants. Clean Energy Ministerial, CEM. This is a global forum for countries to collaborate on the deployment of clean energy technologies. The goals and objectives of these initiatives include reducing greenhouse gas emissions, promoting renewable energy, increasing energy efficiency, and adapting to the impacts of climate change. However, there are challenges in implementing these initiatives, including political and economic barriers, as well as varying levels of commitment from participating countries. Additionally, the urgency of addressing climate change requires more ambitious and coordinated action at the international level. Explain IPCC, UNFCCC, Kyoto Protocol, Montreal Protocol, and Paris Agreement. IPCC, Intergovernmental Panel on Climate Change, is a scientific body under the United Nations, UN, that assesses and synthesizes scientific research related to climate change. The main goal of the IPCC is to provide policymakers with regular scientific assessments on climate change, its implications, and potential future risks. UNFCCC, United Nations Framework Convention on Climate Change, is an international treaty signed in 1992 that aims to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. UNFCCC is the parent treaty of the Kyoto Protocol and the Paris Agreement. Kyoto Protocol is an international treaty signed in 1997 as an extension to the UNFCCC. It established legally binding obligations for developed countries to reduce their greenhouse gas emissions. The protocol required participating countries to reduce their emissions by an average of 5.2% below their 1990 levels by 2012. The Kyoto Protocol's first commitment period ended in 2012, and it was replaced by the Paris Agreement. Montreal Protocol is an international treaty signed in 1987 to protect the ozone layer by phasing out the production and consumption of ozone-depleting substances, such as chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs. Paris Agreement is an international treaty signed in 2015 under the UNFCCC. Its goal is to limit global warming to well below 2 degrees Celsius above pre-industrial levels and pursue efforts to limit the temperature increase to 1.5 degrees Celsius. The agreement requires participating countries to regularly report on their greenhouse gas emissions and efforts to reduce them. The Paris Agreement also established the Green Climate Fund to help developing countries mitigate and adapt to the impacts of climate change. Climate Change Policy Framework. Climate Change Policy Framework refers to the set of policies and measures aimed at mitigating and adapting to the effects of climate change. This framework typically involves national and international policies, strategies, and regulations to reduce greenhouse gas emissions and promote sustainable development practices. At the international level, the United Nations Framework Convention on Climate Change, UNFCCC, provides a platform for cooperation and policymaking among countries to address climate change. The UNFCCC has produced several important agreements and protocols, including the Kyoto Protocol, Montreal Protocol, and the Paris Agreement. The Kyoto Protocol, adopted in 1997, established binding targets for reducing greenhouse gas emissions among developed countries. The protocol aimed to reduce emissions by 5.2% below 1990 levels by 2012. The Montreal Protocol, adopted in 1987, addressed the issue of ozone depletion by phasing out the use of ozone-depleting substances. The Paris Agreement, adopted in 2015, is a landmark agreement aimed at addressing climate change. The agreement sets a goal of limiting global temperature rise to well below 2 degrees Celsius above pre-industrial levels, with a target of 1.5 degrees Celsius. The Paris Agreement also aims to strengthen the ability of countries to adapt to the impacts of climate change, and to mobilize financial resources to support developing countries in their efforts to mitigate and adapt to climate change. At the national level, many countries have developed climate change policies and regulations to reduce greenhouse gas emissions and promote sustainable development practices. These policies and regulations may include carbon pricing mechanisms, renewable energy targets, energy efficiency standards for buildings and appliances, and regulations on emissions from transportation and industry. Overall, the Climate Change Policy Framework seeks to promote global cooperation and action to address the impacts of climate change, reduce greenhouse gas emissions, and promote sustainable development practices. India's response to climate change. NAC and SAPCC. Green Actions of India. India has been significantly affected by climate change, particularly in terms of increasing temperatures, changes in rainfall patterns, and more frequent and severe extreme weather events such as droughts and floods. In response, the country has taken several initiatives and policy measures to mitigate and adapt to the impacts of climate change. The National Action Plan on Climate Change, NAPCC, was launched in 2008, which outlines 8 national missions to address climate change in different sectors including energy efficiency, solar power, sustainable agriculture, water conservation, and afforestation. The aim of the NAPCC is to promote sustainable development while also reducing greenhouse gas emissions. In addition to the NAPCC, various states in India have also developed their own state action plans on climate change, SAPCC, to address specific regional challenges and priorities related to climate change. India has taken several green actions to reduce its carbon footprint and promote sustainable development. Some of these initiatives include National Solar Mission, launched in 2010. The mission aims to increase the share of solar power in the country's energy mix and achieve 100 gigawatts of installed solar capacity by 2022. Energy Conservation Building Code, introduced in 2007, the code sets minimum energy efficiency standards for commercial buildings. Clean Energy Cess, introduced in 2010, the cess is levied on coal, lignite, and peat to fund clean energy initiatives. Pradhan Mantri Ujjwala Yojana, launched in 2016, the scheme aims to provide clean cooking fuel to households living below the poverty line. National Afforestation Program, launched in 2002, the program aims to increase forest cover in the country and mitigate the impacts of climate change. India also played a significant role in the negotiation and adoption of the Paris Agreement in 2015, which aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels and pursue efforts to limit the temperature increase to 1.5 degrees Celsius. Explain in detail understanding of the impact of climate change and specific vulnerabilities related to it. Climate change has a significant impact on the environment, economy, and society, causing an array of vulnerabilities that require attention. Understanding these vulnerabilities is crucial for effective policymaking and implementation of adaptation and mitigation strategies. Some of the most prominent impacts of climate change include rising temperatures, changing precipitation patterns, sea level rise, and increased frequency and intensity of extreme weather events such as hurricanes, floods, and droughts. These changes can lead to a range of environmental impacts such as melting of polar ice caps, ocean acidification, and biodiversity loss. The effects of climate change also have significant social and economic impacts, including food and water insecurity, displacement of communities due to natural disasters, and damage to infrastructure and property. Specific vulnerabilities related to climate change can vary based on location, economic status, and social factors. Vulnerable populations such as low-income communities, indigenous populations, and people living in coastal areas or arid regions are particularly susceptible to the effects of climate change. These communities may face challenges such as limited access to resources, inadequate infrastructure, and exposure to health risks, making them more vulnerable to the effects of climate change. In addition, certain industries and economic sectors may also be vulnerable to climate change impacts. For example, agriculture and tourism industries may be adversely affected by changes in precipitation patterns, while coastal regions and cities may face challenges related to sea level rise and increased frequency and intensity of storms. Overall, understanding the specific vulnerabilities related to climate change is essential for developing effective strategies to mitigate and adapt to its impacts. This requires comprehensive research, data collection, and collaboration across sectors to identify and address the most pressing vulnerabilities. Explain in detail knowledge about designing built environment with respect to adaptation, mitigation, and resilience associated with climate change. Designing the built environment with respect to adaptation, mitigation, and resilience associated with climate change requires a comprehensive understanding of the impact of climate change on the environment and the society. Architects, urban planners, and designers have a crucial role to play in addressing climate change challenges through their projects, by designing and constructing buildings and cities that are sustainable, resilient, and energy efficient. The following are some key principles that guide the design of built environment for adaptation, mitigation, and resilience associated with climate change. Passive design strategies. The first step towards designing a sustainable built environment is to adopt passive design strategies, which reduce the energy consumption of buildings through the use of natural ventilation, daylighting, and shading. Passive design strategies help in reducing the carbon footprint of buildings and help in mitigating the impact of climate change. Low-carbon materials. The use of low-carbon materials in construction can significantly reduce the carbon footprint of buildings. Materials such as timber, bamboo, and other sustainable materials can be used as alternatives to traditional building materials such as concrete and steel, which have a high carbon footprint. Energy-efficient systems. The use of energy-efficient systems such as high-efficiency HVAC systems, lighting, and water heating systems can help in reducing the energy consumption of buildings. Renewable energy sources such as solar, wind, and geothermal can also be used to power buildings. Green infrastructure. Incorporating green infrastructure, such as green roofs, rain gardens, and permeable pavements, can help in reducing the urban heat island effect and mitigating the impact of flooding caused by extreme weather events. Adaptation strategies. Designing buildings and cities that can adapt to the changing climate is essential. Designers must consider the potential impacts of climate change, such as increased heat waves, flooding, and extreme weather events, and design buildings and cities that are resilient to these impacts. Community engagement. Engaging with local communities is crucial to the success of sustainable design projects. Understanding the needs and priorities of the community can help in designing buildings and cities that are adapted to the local context and that can be resilient to the impacts of climate change. Life cycle analysis. It is essential to consider the full life cycle impact of buildings and cities, including their construction, operation, and demolition. Understanding the carbon footprint of buildings and cities throughout their life cycle can help in identifying areas for improvement and reducing the overall impact on the environment. Overall, designing the built environment with respect to adaptation, mitigation, and resilience associated with climate change requires a multidisciplinary approach that considers social, environmental, and economic factors. It is essential to engage with local communities, use sustainable materials and systems, and adopt passive design strategies to create a more sustainable and resilient built environment. Explain familiarity with frameworks for addressing climate change. Familiarity with frameworks for addressing climate change is essential for understanding the various policies and actions taken to mitigate and adapt to climate change. Here are some key frameworks. United Nations Framework Convention on Climate Change, UNFCCC. The UNFCCC is an international treaty signed in 1992, with the objective of stabilizing greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous human interference with the climate system. The treaty was ratified by 197 countries, including India. Intergovernmental Panel on Climate Change, IPCC. The IPCC was established by the UN in 1988 to provide scientific assessments of the risks of climate change. The IPCC's reports are based on the work of thousands of scientists from around the world and are used to inform policy decisions related to climate change. Paris Agreement. The Paris Agreement is an international treaty signed in 2015 under the UNFCCC, with the goal of limiting global warming to well below 2 degrees Celsius above pre-industrial levels, while pursuing efforts to limit the increase to 1.5 degrees Celsius. The agreement requires countries to set their own emissions reduction targets and report on their progress. National Action Plan on Climate Change, NAPCC. The NAPCC is a comprehensive plan developed by the Indian government in 2008 to address climate change in the country. The plan includes 8 national missions focused on various aspects of climate change, such as renewable energy, sustainable agriculture, and water conservation. Sustainable Development Goals, SDGs. The SDGs are a set of 17 goals established by the UN in 2015 to promote sustainable development worldwide. The goals are interconnected and address a range of issues related to social, economic, and environmental sustainability, including climate change. Sendai Framework for Disaster Risk Reduction. The Sendai Framework is a global plan for reducing disaster risk adopted by the UN in 2015. The framework aims to reduce the number of people affected by disasters, increase the resilience of communities and infrastructure, and strengthen international cooperation on disaster risk reduction. These frameworks provide a basis for governments, organizations, and individuals to understand and address the challenges of climate change. By aligning policies and actions with these frameworks, it is possible to work towards a more sustainable and resilient future.